the channel. I'm Mrs. R. Let's do some math.
Today we're talking about graphing lines when you're given slope-intercept form. So just a refresher, slope-intercept form looks like this, y equals mx plus b. And it's called slope-intercept form because your slope is represented in that m spot, that coefficient of x, and your y-intercept, so that's when we say intercept here, we're looking at the y-intercept, that is that constant number at the end. Now, positive numbers, negative numbers here will mean something different, but we'll talk about that in our examples. As far as a process here, what we're going to do is look at the equations. We're going to first identify the slope and the y-intercept. Let's put these in a little checklist. Step 1, identify slope and y-intercept. Then the second thing we'll do is plot the y-intercept. Now, when we say y-intercept, we mean that's where your line is crossing the y-axis. It intercepts the y-axis. So your coordinates there, your x-coordinate is always going to be 0 because this is on the y-axis. And then b is how far up you go on the y-axis. Then from there, we're just going to count the slope to the next point. Remembering that m equals, we call this the change in y over the change in x, or rise over run. And then the very last step, use the dots or the points to draw your line. So these are the steps we're going to do. And we're going to do these for all of the examples. And then you'll see that this is an easy thing to do, and hopefully it'll be one of the fun things for you. So let's look at our first example. We're going to graph this line. The equation is y equals 7/2 x minus 2. And you can see we are in slope-intercept form. Our y is all by itself. We've got this number in front of x. We've got this constant at the end. So as far as identifying, our slope is 7/2. Our y-intercept is -2. So anytime you're looking for your y-intercept, you're going to keep whether it's positive or negative based on the plus or the minus right here. That's very important. So we've identified our slope and our y-intercept. The next thing we're going to do is actually plot the y-intercept point. And remember, that means we're going to plot it at 0, -2. So I'm looking, and we start at always at 0, 0. I don't go any left or right. I just go -2 on the y-axis. So there is where our line is going to cross the y-axis. Now our slope of 7/2, this is where we're going to count. We're going to rise 7. 1, 2, 3, 4, 5, 6, 7. It's a rise of 7. And then we need to run for 2. 1, 2. So ultimately, I counted up from my y-intercept. I counted up 7, and then I counted from that level to the right 2. That's my second point. Then what we're actually asked to do is graph this line. So if you just leave it with the 2 points, that's not going to be enough. We need to have this line here also. Now you want to do your best to go through the actual center of the points where the grid line was. This is trying to click me into weird spots though. That's pretty good. And it is a line, so if you were in my class, I would have you put the arrows on it because lines are infinite, but there are different teachers who say different things about that. So make sure you pay attention to your teacher. If this is helping you get started on your homework, do it the way they want you to do it. But you do ultimately have to connect the dots, extend the line past those dots because that's what a line does. But that's the answer. That when it says graph the line, the actual black line with the arrows on it, that is my answer on the graph. So we're done with that one. Let's go ahead and look at the next one. Here we go. We're going to graph the line y equals 6x plus 3. So again, our first step, identify the slope and the y-intercept. The slope here is going to be 6 because that's the coefficient on our x value. Our y-intercept we can see is positive 3 because this says plus 3. So next step would be to plot this y-intercept point at 0, 3. So here's our y-intercept. And now our slope, though, our slope is 6. We're expecting this to be a fraction, rise over run. But remember, any whole number can be written as itself over 1, and that gives us rise and run. Now here's where things get weird. I'm supposed to graph this line on this grid. This is the grid that I was given, but I can't count up 6. 1, 2, 3, and then who knows what happens up here? I can't count up 6. So one of the things to remember, obviously 6 is a positive number, right? But when we're thinking about a fraction, I know positive divided by positive gives you a positive. So that's how I had this 6 over 1. But a negative over a negative also gives you a positive. So if you ever get a slope that you can't physically count on your graph because your graph is too small, try using the double negative version of it. Your slope's the same. You're just going to be kind of counting backwards. So instead of counting up, this rise is negative, so it's actually going to be a drop. I'm going to count down 6. 1, 2, 3, 4, 5, 6. So now I'm here. I've counted down 6. And now that negative 1 for our run, that means we're running backwards 1. So we're going to go to the left. And there's my new point after going that negative version. Now, if we kind of pause and reset, if I had started with this point, then I really could have gone 1, 2, 3, 4, 5, 6, up 6, over 1. And look, I'm at my other point. But we had no idea that we needed to start at -1, -3. What we did know was the y-intercept. So that's where we started, and it kind of forced us to count our slope backwards. But hey, that's all right. We still found it, and we still can make our line now as we go through those 2 points. Now, if I were you, I would erase, if you actually marked as you were counting, I would erase those marks. But you probably didn't mark it. You probably just counted down with your pencil. But that's graphing a line. Now, I do have a couple weird examples for us. We got to get some weird examples. Now, if you watched my videos on slope, you've already seen an equation that looks like this. So we're going to graph the line y equals 4. Now remember, our first goal is to identify the slope and the y-intercept. But this doesn't really look much like slope-intercept form. We have to think about, if this is y equals 4, what does that actually mean? That means that every single point on this line, all of those infinite points that make this line, they have 4 as their y. So if you listed a whole bunch of points, like 0, you'd have to have 4, and then 1, 4, and then -5, any x value, but it's always going to have that 4. 4, 4, 4. If I started plotting these, look what happens. So I don't go any left or right, but I go up to 4. 1, 4. -5, 4. These are all lining up horizontally. If you have a y equals number, basically all you have is the y-intercept. Because your slope is 0. There is no rise here. The y is always 4. There is no change in y, so it just goes straight across. All right, and then the next one. Ooh, x equals. This means x is a constant. That means there's no change in x. Which means, so we have our x being -2. That means we're always looking at -2 as our x coordinate. So we could have -2, 0. We could have -2, 5. We could have -2, -3. No change in x. That means this is going to be a vertical line. So there's one of the points I listed. There's one. So there's no run here. We just have rise. Now another way to think about this, when it says x equals -2, kind of like y equals 4. 4 was our y-intercept. This is like our x-intercept. It's not something we talk about a lot, but that would be our x-intercept. So I can see we're intercepting x at -2, and then we just go straight up from there. We don't actually change left or right. So that's the basic idea and some weird examples on how to graph lines based on a slope-intercept equation that you're given. We'll put this one back up here for our final view. So if you found this video helpful, I would absolutely love for you to hit like there and maybe leave a comment letting me know. If you'd like to see something else made, leave a comment and we'll try to get that video made. But any interactions at all help us get these videos out to more people so that they can get help too. And I just want to thank you for joining me for this talk about graphing a line from slope-intercept form. I'm Mrs. R, and this has been Me Doing Math. I'll see y'all next time.